Hello again, and welcome back. I took a short break there the last few weeks, but back again with writing a programming language in Rust. Continuing on with this NORPL research programming language that will eventually be developed into a more, I suppose this is kind of the research phase of designing a more practical, domain focused programming language. And at the moment, I'm just putting kind of the final touches, what I hope are the final touches of the research part, and then hoping soon enough to start working on actually adding some of the kind of specific features that are intended to make this kind of language a bit more special and a bit more practical. What's there now so far is kind of your standard programming language. I have a bunch of features down here listed in the kind of done section of my to-do list. And if we take a look at some of the test scripts, we can see that, most of the features done so far, your kind of standard programming language features, fairly kind of bland and inoffensive. And once that kind of generic core is done, I'll be moving on to the kind of more full-featured language, which will be targeting basically the same domain as Bash scripts, but effectively trying to replace Bash scripts with a slightly more structured approach, and I suppose a bit more consistent approach based on what we might expect from programming languages in general, but still trying to keep the ergonomics and ease of use that that Bash has, because Bash does have a lot of things going for it. So it's keep as much of the nice things as possible, but give a kind of perhaps a fresher interface and more consistent semantics. So with that said, I'll just pop open the to-do list again. And we're kind of coming up on the last number of features now that I'll be looking at. So I actually had added a few notes to my notebook since last time on a few other small features to be done. So some of the main ones that we have here are for loops. So we have basic for loops, which basically just iterate over the values of a list. I'll be updating this to actually for loops to handle objects and strings. In fact, do I have while loops? Yeah, I have while loops. So I'll be looking at iterating over objects and strings. Strings, based on my what I've decided so far, would probably just be, so we won't be taking the kind of Go and Rust approach of being kind of valid UTF-8 strings always. This will be kind of a somewhat of a wrapper type just around kind of plain byte arrays, just for ease of processing. And then there'll be kind of library methods to manipulate strings to handle UTF-8. So there'll be two parts of that. So in fact, I might just add that up here to split those up. So there'll be kind of for loops, and the intention here as well is to extend these so that not only will the for loop iterate over the values, but we'll also be able to capture the keys as well as we go. Of course, these will be ordered iterations. The object iterations will be, it's not necessarily that they won't be ordered, but the order of evaluation will be undefined. Or I suppose, yeah, just won't be well defined. And then for the second half of this, or not the second half of this actually, but this will be more to do with In fact, I see I have a flow section down here that I can put up there. Another thing I'd like to do, so I've done most of the object destructuring, more or less all of it, I think. Hello, Harold. Nice to have you on the stream. Thanks for joining. So we have, in fact, this kind of refers to, these two sections refer to more or less the same thing, but one additional area of destructuring that I want to look at soon as well is we have destructuring in kind of specifically in assignment statements. So I'll be looking at destructuring in the context of kind of different areas. So specifically in the context of for loops, so that we can do, if we have, for example, with the enumeration for loops, we'll be able to do things like for kv in object, stuff like that. And this destructuring isn't implemented now, I don't think, but will be something that I'll be adding. So there'll be destructuring in for loop variables. So basically any construct that can introduce a binding should ideally allow destructuring. So that's essentially for loop variables at the moment, and function parameters, I believe. But I can take a look for other bindings. So we've that. One other thing. So one thing I have decided not to include in this language after, and again, this is the research phase, or the research language basis for a fuller language that will have more of the kind of more potentially features that could introduce kind of debate. But I won't be including support for kind of a lot of features in this language are based on kind of JavaScript, and particularly the kind of inheritance model is based on prototypes. But I won't actually be introducing prototypes the way they are in Java into this research part of the language. So we won't be able to do nice things like, for example, string length. It'll have to be instead, there'll probably have to be a library called strings, which exports length, and then you call that on a function. So it'll be function call syntax rather than kind of method style syntax. So that's one thing that I won't be doing in this language. Another few bits to add. Let's see. Yeah, one thing that I'd intended from the start but actually kind of forgot about is, so we have, let me see where indexing is. Yes, so we have array indexing at the moment, but we don't have range indexing, and that's something that I would like to borrow from Python and Golang and all the rest of them. So we can define a range like this, and this can be applied to both arrays and strings. One aspect of this that I was thinking about before as well is, will I allow the Python approach of allowing negative indices? I've actually decided against that because it can actually potentially hide mistakes, I feel, and I think I will actually take the Go approach of requiring explicit positive indices, and if you want to get kind of the second last index, you'll have to do that relative to the length of the array. Harold P says, did I use any main resources to learn about this? I've looked at tinkering with making a new language before, but the resources available didn't seem to be that great. Yes, it is a tricky one. I do think resources in general have improved over the years, but for my own background, I was kind of fortunate enough that I just kind of happened to kind of learn this stuff relatively organically throughout my kind of years of programming. And I suppose two of the kind of I suppose standout areas where I had good opportunity to learn about this stuff is in college. There was specifically a course on compiler and language design, I believe. Um, I had actually I'd actually kind of looked into this stuff before that, kind of looked at the Dragon book a little bit. I think there was a book called uh, probably designing or writing a programming language in Java, things like that. At the time, those topics didn't really make too much sense, but I feel that the course itself kind of just helped solidify everything. There was also a um, yeah, and I think there were kind of similar courses where we had some nice courses on functional programming in college where we didn't necessarily write, languages, but we kind of use we we did do, I believe, an interpreter uh, for Forth or for Factor, which is I think based on Forth. And while it basically it's basically a postfix style programming language, so the semantics are the lexer and kind of parser semantics aren't too sophisticated, so to speak, but it kind of gives you an idea of how to handle kind of program evaluation and how to evaluate ASTs and things like that. Well, maybe not ASTs strictly. I also had a bit of kind of familiarity with Lisp, which again helps because it just, the language itself is an AST, so to speak. It's kind of this kind of can't remember the term, but iconograph or icon something language, which basically means the language is written in its own, is a mirror of the how do I describe it? It's a mirror of this. No, I'm making a hames of this now, but the language itself, the data, the way it's written is the same. Data and programs are kind of interchangeable. So you can basically create a data structure and it'll just it can be kind of evaluated fairly simply because the data is in the same structure as the program in general. Um, but I suppose the main thing that solidified all this stuff for me was basically just getting an opportunity to apply it practically in a job scenario. Because one of my first internships, I happened to be involved in basically there was a company. They were um, kind of someone had written a programming language for one of their tools. They wanted to build it out, and I was kind of heavily involved in that. I was writing tests for it and things like that, and just have basically being able to go into a compiler and dig through it and things like that was tremendously helpful. Um, Harold P says, I would have thought there would be lots of people that would have done similar, was trying to fish out some web articles, but there's not many complete tutorials for it. Yes, that's what I found in the past. The one reference that, in terms of a a kind of what seemed like a complete resource. I never actually got around to trying it out fully, but and this is kind of quite old school now at this stage. I'll actually try and find it on Google rather on Ecosia because it's a bit niche. Um, it was something like building a toy programming language, maybe from scratch or possibly for fun and for profit. Like this wasn't even a website, so to speak. This was kind of you know, a series of .txt files that you kind of, zero formatting, zero of anything like this, but the content at the time that I was looking into this stuff anyway, originally, what it was kind of, it was the kind of highly recommended one, and the brief bit I did on it, maybe I'll try for fun and for profit. Yeah, I'm not sure if I'd even be able to find it again now. It's no, it was a very old series of articles now. There was about 15 or so, and again, just plain .txt files, 80 character width. But at the time, as far as I found, I suppose the benefit of this book, or I'd looked at books before as well, and there's the Dragon book, of course, which is kind of seems to be the definitive resource, but it is quite theory heavy. I found it kind of very difficult to break into myself, especially when it came to things like LR grammars and things like that. Then the other resource, kind of writing a programming language in Java. Again, even just getting through the ideas in terms of handling tokens and scanners, even though it's there are even tools that just handle that for you now, is kind of, a lot of these resources tend to be kind of a bit heavier on the theory side. But if I recall correctly, this kind of writing a toy programming language series was a bit more kind of just walked you through it. Harold P. I started reading one and I was like, looks good. And then there's only part one, references part two, but there's no part two. Yeah, exactly. It was very likely in the 90s that I would have come across that .txt series. I suppose one resource that I might mention, because I know, like, there are various ways to learn this stuff. Like you mentioned, there might not be too many kind of solid resources that take you end to end, but one resource that actually inspired me to kind of get stuck back into writing this language, and that I kind of used to actually understand for example, I use a framework called LALRPOP to generate a lot of the kind of scaffolding for this project. And the way I came across that, and I sometimes use it as a reference when I can't get any joy from the actual LALRPOP documentation. Let me see if I can find it. Basically, there were a couple of programming languages posted on Reddit by who I have to say is a very talented young person. I think they're kind of just recently in college. I think I can find a link to the repository. Oh, why isn't it in my Git history or my browser history? Let me just check here. Maybe I have it in my starred repositories. My stars. No. Oh wait, I can find it easily enough. Basically, one of the projects that he wrote is the Oaksy. Yeah, Adam McDaniel. So so this person has a number of projects written in LALRPOP in particular, and you know it depends on your kind of level of familiarity, but just having a reference language, and especially I found some of these kind of a bit more lightweight, so they're a bit easier, a bit more comprehensible. Let me see what other ones. Oaksy was the kind of main one. Dune, I don't think was incorporated a language. Let me double check. I think Atom was a shell project that incorporated a language, and maybe OXC references another one. Yes, there was free as well. So again, to be honest, I haven't looked too much into these languages myself. They seem very interesting. They kind of take different approaches to programming. This is, I believe, oh yeah, and this other language is based on another language as well, which is based off of the Brainfuck programming language. And there was this series of programming languages that I was kind of looking at and saying, you know, it like I suppose that's complicated enough, but it's probably more lightweight than say, if you were to look at the likes of I don't know an actual say production language like Python or Golang or things like that. Although Golang isn't too bad, but I suppose the benefit of looking at, say, slightly smaller projects like these, like for example, this language has kind of very few productions and things like that, but they can at least get you started. I feel with just being able to play around with something that is fully implemented, and even if there isn't a resource to kind of take you through it end to end, these can be used. These can be used to maybe as a learning resource, kind of to use side by side with kind of another reference. What I would say is, I'm not necessarily touting this stream, but if you, I am post as I edit them, just to trim off the excess parts. I'm putting these live streamed episodes up on YouTube as well. And while I don't necessarily go into the kind of deep part of, lexers and parsers and things like that, like how to develop those things manually, I do kind of build the language that I'm writing now is being built from the ground up. So, and using the LALRPOP framework. So, if you were to start on those videos, you would at least see. So you wouldn't get the kind of all the information on token streams and kind of turning those token streams into ASTs, but you would be able to see how an AST can get constructed piece by piece. Like I start with very basic elements, starting with a series of statements, add in if statements, while loops, and you can see how the AST can get transformed from basically a program, can translate a program description into a kind of a structured flow, and how those kind of almost dead AST elements can then be evaluated into living values in memory. Now there is a bit of battling with the Rust compiler as well, so it probably isn't the smoothest journey to learn about programming languages themselves in the most theoretical sense, but at least gives you a kind of I am starting from the start of this programming language, and you can see how it's built up over time and how the evaluation gets built up. Like it's still just an interpreter is the other thing. So there is a difference between how you develop an interpreter versus a compiler, but those are kind of nearly add-ons rather than a lot of the time the core is necessarily the same. Um, that's great. I'll have to check them out. Cheers for the help. Anyways, got to run. Yeah, you too, Harold P. Thanks very much for the questions and for joining the stream. Have a good day. So yeah. So with that all said, and yeah, just for anyone kind of still watching the stream as well, always a good place to start with compilers is LL1 kind of recursive descent recursive descent interpreters, they're just a bit simpler than, for me anyway. You can actually kind of hand roll them a bit. If I think I did a bit of messing around with the Golang compiler early on when it was being I know, like after its kind of 1.0 release and stuff back in the day, and it wasn't. I think that's done using Bison, but um, I think the actual evaluation, was that how it worked? I think there was a certain level of kind of handwritten kind of evaluation in there. It wasn't all kind of I don't know, action branches, or I'm not sure what the proper names it are, but there, I think there was a good level of hand rolled LL1 evaluation in there, and I think that was kind of the reason for the design of Golang to be designed that way as well. That it could be kind of the evaluation was designed to be very simple. But anyway, that's a bit of a tangent. Just another potential resource for anyone interested in getting started with writing programming languages and compilers and interpreters. Definitely start with interpreters, I would suggest as well. Always a good place to start. Anyway, back to our regular programming. Just continuing on with this. So we will be disallowing negative indexes or indices, and a range of a string will also return a string, and a range of an array will return an array. So even if it's one element that it's accessing, if it's using the range syntax, then the result will be an array. And the one shortcut then is you can omit the start and or end index to specify the start or end of the item, or of the source. So yeah, the next one is full extended for loops. So that's yeah, basically that was just my notebook way of specifying enumeration and destructuring. In the stream, I also want to demonstrate closures, because I think that's something that the language actually handles already, but it isn't something that I've actually gone through specifically in the stream. So that would be nice to kind of demonstrate and kind of prove that it works as well, because if it doesn't work, then that's something that I want to fix and make sure it works. One thing that I just realized I didn't note here as well is, whoops, I'm after losing my train of thought. That's all right though. Number 6 then, I do want to, even though I won't be adding prototyping, I do want to add a lightweight syntax for this. There are loads of different approaches to how this can be named. I think a lot of languages call it self, such as Python and Rust, and Java and JavaScript tend to call it this, and then go take other languages. In Python, you can probably call it something else, but there's just the convention to call it self. And then Go takes that convention and says, well, the kind of context object is just another parameter, so you can call it whatever you like. I've used all of them. I think this personally is just kind of one of the easiest ways to go about it. It's just even though this in JavaScript means something a little more I suppose interesting to say the least, but I'll just be taking the approach of if you call a method on if you call a method and it's a field of an object, then the object will be passed to that function as under the this binding. So basically, it's just a shorthand realistically, because you can kind of more or less achieve the same thing in a more roundabout way. So if I wanted to have I can achieve the same thing using closures. So for example, if I wanted to have a special, well, it wouldn't quite be the same thing, but I can kind of approximate it. So if I had, new X, and it was going to be a special type of object, and it's going to be an object that keeps, or it's a counter, whoops, then, if I was using this, then I could define um, a new object, and it could have maybe, and I can use the kind of Python convention of underscores for private variables. I can have a value here, and then I can have an increment function, which in the context here, this is just added to the scope of the function when increment is called. So and so then print C, maybe I just call that val. But that if I wanted to kind of approximate that, I could kind of, by basically creating a the val binding before in fact, in this language, I don't have let. Actually, that's that is, I think, the thing I wanted to add as well. So we could return here val, although that wouldn't quite be the same thing, because that would copy the value, so it wouldn't be quite the same thing. You'd have to have getters and setters, which makes things a little more complicated. But you could still have this kind of increment function, and you could create a getter to retrieve the value, and val plus equals 1. It's an approximation. I've decided that I'll just have this kind of lightweight, well, intended to be lightweight approach for kind of enabling nicer method syntax. And then, yeah, the last thing I'm thinking is to introduce let and const. So I'm still going to keep the approach of, because I do like it, of requiring that variable declaration has to be paired with instantiation. So, you never give a value like there aren't going, sorry, there aren't going to be, oops, apologies, there aren't going to be default kind of initial values in this language. You'll have to kind of assign them explicitly, but I've decided to replace the possibly more light, it could be considered more lightweight declaration syntax here with something like this. And there are two reasons for this. Number one, this syntax allows us to have a complementary mechanism where if we use let, we can introduce a scoped variable that can be kind of rebound or kind of can be assigned a new value, and then the constant or the const declaration means that it can't be given a new value. So we're kind of familiar with this from another of current languages already, such as JavaScript. And one of the other advantages of this is, while I do like this, realistically, I could see this being kind of a blind. You probably can get used to it, but I do see this as potentially being a bit of a blind spot. So you want to see, oh, where did this kind of variable get defined? Where did it get introduced into the scope? And my inkling is just that this might be a little, it could easily be overlooked, I feel. Whereas these kind of syntaxes, while they're a little, a little bit more typing to them, they're quite explicit, quite distinct. You can kind of, I would say, clearly identify them in a certain scope. So for that reason, just to be pragmatic, I'll miss my little kind of neat colon equals initialization, but I think this is the more kind of pragmatic approach. So with that all said, yeah, I've been talking here for over half an hour now, so might as well get started with some actual programming. So so to start with, let's take a look at which one of these. Well, first of all, I might actually get started with these guys because they should be kind of a quick one just to knock out early. So let's see here, and this, like, the let declaration anyway should be more or less just a drop-in replacement for the colon equals mechanism. The kind of distinction here with kind of a number of other languages is that you can't you actually have to assign it a value. So declare in this sense is actually a bit of a misnomer. Like it's declare and assign, whereas this is just assign. But anyway, that could just be splitting hairs. No, it's not actually, because they are very different things. So what I'll do is I'll start off with let, and that'll basically just be a oops, why isn't that running? Oh no, it's down here is my little oops, my little area that rebuilds the code every time. So yeah, unrecognized token, so I must be using yeah, of course I would be using the existing declaration syntax that I need to replace with let. And so that's probably all I needed to do to implement the let part of it. And in fact, I'll go back to the to do, and that will be done. And oh, actually, one way I've changed my environment recently is in my home directory. I believe I created no, that's not it, is it? Yes, I created a bunch of scripts to replace my oh, what are they called? To put into the likes of my hooks directory to make to simplify my hooks checks, because I tend to implement the kind of same thing in different areas, and they often have subtle bugs, such as the fact that this one doesn't actually check that no commit is in the new files or in the new changes. It just checks, do any files contain no commit? Whereas I think I've resolved that issue in these new scripts. So what I might do here is I'll add Dropbox home scripts git pre commit.sh, and that should use my new scripts for my new pre-commit scripts. So if I then do git commit, and what will I say here? Replace that with let syntax. And yeah, so even though my old pre-commit would have failed there because I go grep n recursive, I exclude their target, no commit, and I would have found a bunch of files that contain that, even though they're not actually, being committed. So so that avoids that issue. So next thing to go on to then, let's check the to-do list again. For loops for enumeration. Now this will be a bit to unpack. The list one should be straightforward enough. So if I do something like, so this will be changing, and I'll just copy the current test as test5. So what I'll be doing here is I'll be saying for maybe pair in one, maybe A, B, C, print pair, and then the same thing I can do IV, print I, print V, something like that. And that should allow me to just print all the kind of index value pairs, and same with this, but they'll all be on independent lines. And so that'll be changing how it's evaluated. So yeah, can't destructure non-list into list. Oh, so maybe this already supports destructuring, I'm not sure. Because the first one, yeah, I suppose I'll focus on the first one first. And this at the moment just outputs the oops, did that modify the rest of, yeah. So that just outputs the values at the moment, but I want to update that so it outputs we get an index as part of the array pair. So what I'll need to do for that, excuse me, I'm very, yeah. So where will I need to jump to? I'll need to, yeah, the for loop, and basically in this section where we're assigning a value to the left hand side, and now what we want to do is basically add an index here. Oops, Rust allows plus plus, doesn't it? So we have that. We have pair is equal to, so that'll be a new, so I have to do a couple of things here, I think. So it'll, oh, I'm messing with the totally wrong file. Yeah, I was wondering why the syntax highlighting was off. So yeah, we have a list here, list of x's. Let I equals 0, that'll have to be mutable. I will increment down there, and let's see, x's remove, so let val is equal to that, and then let pair, we call pair our entry. Entries are what are used for objects typically, so in that case we might keep the language consistent, so or the terms consistent. So in this case we'll call it an entry. That'll be a new value. It'll be a new val ref, and it'll have to be a list of x's, and it'll consist of 2 entries. The first of which will be I, which will need to be a new val ref as well. So that's an int n, which will be I, and this will have to be, it's already a value, so we just put, in fact, it probably doesn't even need, it's probably already a new val ref as well, so I probably don't need to do anything with that. We'll try that anyway. So we bind the entry to the item expect expression. Maybe Rust doesn't have the that increment syntax. Cool, and yeah, that's what we expect, or what I would have expected anyway. So we have 0A, 1B, and 2C. So yeah, I'm actually just going to commit that as is. And let's see, add support for list enumeration in for loops. And with that done, the next one I wanted to try, and I'm not sure if this, again, it's so long between these streams that I forget what things are actually implemented and how. So this might already be done, this kind of destructuring syntax in the for loops. That'd be kind of a nice thing to get for free, but oh, that's just happening because of the silly way the comments are working at the moment. And yeah, okay, so that's actually working already. So nice one. It looks like the and can I do the same in functions, I wonder, actually. So if I have a, let's see, let's try A and B in a function declaration, and print A and print B, and it's going to be a function f, and I call f on 1 and 2, does that. And just to make it a little more complicated, I'm going to put it into a variable first. No, so that's actually an issue at this kind of parsing level. So it potentially would work if function arguments could be parsed as expressions. But yeah, that's just something to yeah, let's see, can I add it now? So first of all, what I'll do is, oops, I'll go into my to-do. The for loops list enumeration is done. So I'm going to take a look at, and destructuring for loop variables was actually already existed. And so destructure bindings. I'm kind of duplicating stuff here somewhat, but so destructure bindings, and there's for loop variables, and I think that's all right. So maybe I'll put this under assignment. And objects could be all right, actually. Maybe I suppose I'll take a stab at destructuring function parameter bindings first. So with that done, yeah, so this will potentially just be a syntax level change, because if it works for destructuring in the for loop, then there's a good chance that it'll work for assigning for binding function parameters as well. So place I need to go is where param lists are parsed, and this will need to then be, so for a param list it's going to be, it looks like that already allows already looks for expressions. So what, maybe I was looking at the wrong line. So I'll open up my test again and just put everything onto one line, just to double check where the syntax error was getting raised. So token 25, was it? Token, no, token 5. Yeah, so it is that one, unrecognized token. Expected, it basically expected a closing bracket or an identifier. So, oh no, I was looking at, so that's a param list rather than yeah, rather than an arg list. Would it be very silly to just do, now one thing that I'm not too happy about is it could be just introducing kind of a lot of behavior that I'm not fully aware of. So what I'm thinking is I'll go to where arg names is being defined. And this would be a param list instead, and the function. So the args instead, yeah, the args will still be like that, but now they'll be a vector of expressions rather than a vector of strings. So first of all, I need to update the AST so that that's respected, and then yeah, let's see how this goes. So function definition bind name, that just creates the new function binding, and it stores everything. And then when the call is made, is where I'll now need to do, instead of creating the inner scope with, and just to double check, yeah, so this isn't going to be relevant for built-in functions, but basically, yes, I'm creating this inner scope, and it's just creating the bindings or adding names to the values, and that's kind of a relatively naive, so to speak, approach, or just a very plain approach. It's just kind of adding the names in a hash map. Whereas what I'll probably want to do now is, oh, I wonder if this will even be possible, because I remember this was to work around a certain level of Rust ownership limitations. So where should I jump to now? If I take a look at the for loop implementation, then I can see this. So it takes scopes. It's surely creating a new scope somewhere as well, I assume. So we've eval statements in new scope. Oh, that could be a bug. Am I adding the actual am I adding the new binding in the enclosing scope? How would I test that? I can test that for now. Arg names. So I need to fix that first before I can test this, and I won't work on the functions just yet. Oh, but that'll be tricky. Ooh. It's kind of a work in progress at the moment. And maybe if I do a git stash and just go back to where I was. And if I take a look at that, so we have this printing pairs. And the question here is, can I still print the last pair? And if so, that's a bug. Or at least it's a bug in my regard, yeah, in my language. Yeah, so I don't want that to escape the scope that it's meant to be defined in. So what I might do is try and do a quick fix for that. So if I go for, so instead of, so this will be eval statements in new scope. So this will have to be the way for any, in general, any kind of block operation that introduces a binding. Some languages like Go use the, so I'm just thinking, if I were to, like, I think the simplest approach would just be to create a new scope and then kind of destroy it on the next iteration. But that could be inefficient. And the way Go does it is it just has one kind of memory cell for whatever the iterator is. And, I'm not sure if that's, if there's anything wrong with that, but I suppose I haven't thought about it too much. I know it does cause issues sometimes, but like the fact that if you're spinning up another Go routine, you'll face issues because all the Go routines will be referencing the same memory cell, even though you might be expecting it to reference an old one. But then it has the benefit of being, that doesn't really surface as much, and it just once you figure it out, it's a bit of a gotcha, but you can kind of avoid it from then on. But then it is just, I assume, a lot more efficient to just have one memory cell. So yeah, but to emulate that would just be a matter of taking this out of the main loop. But this might just be easier. I'm not sure. Like assigning a new bunch of data every loop. Yeah, it's probably not ideal, but it's probably not the end of the world either. So is that the best way to create a new scope? So we have a scope stack and a new scope. Okay. So what I'll need to do is eval statements. Of course, shadowing R up there, but that should be all right. Again, yeah, this is very like this is getting into very deep work in progress territory. Like these are, doing some pretty bad code here, but could do is so this is how I'm creating, probably creating a new scope below. So is there a hash map literal? Maybe I'll just take a look at these standard examples. So it just does insert. So yeah, I think I do want the scope to be destroyed from one iteration to another. So this will be kind of let inner scope. Oops. Hash map new. And it'll just figure out what I want. I'll just keep that around just in case. Can I give it any initial values? I can give it a capacity. Hasher. No, I have to put it on 2 lines, like a I don't know what, but I suppose that's not too bad. Hash map new, inner scope insert. The name will be, oh no, it won't be insert actually anyway, so it'll be bind maybe what I can do is can I do let inner scope, and I'll create scopes new from push. I'll push a new blank scope. I might have to tag that, I'm not sure. Then I can bind I might have to refactor something else to allow this, but bind only really needs to be able to bind. Oh no, it needs to have access to the full bind needs to have access to the full scope stack in case a binding exists, and if it's an assignment, it'll bind somewhere in the scope stack, but if it's a declaration, it doesn't need to go up the stack. I don't necessarily want to do an optimization, but I do wonder if there's some way I can simplify it for that case. So if where's the definition for bind? So if bind type, yeah, in the case where bind type is a declaration, the full stack isn't needed. We can just do that on a hash map. That's a good way of capturing that. While ideally also taking advantage, like, how do I also take advantage of the commonality between a declaration and an assignment, while also, you know, kind of taking advantage of this property of a declaration. And the reason why I'm getting so caught up on this is that I have two basically helper functions for evaluating statements essentially in new blocks. And the first of these assumes that no values are introduced in the new block. And so it basically just creates a new empty scope and just pushes onto the scope stack and evaluates the statements in that new scope. But this one assumes that the inner scope is this takes the outer scope basically and the inner or the outer scope stack and a new inner scope kind of frame as a hash map under the assumption that we can just push that frame onto the scope stack. It just doesn't work quite as nicely with this section because I'll be wanting to push because I'll be wanting to do that push outside this eval statements program or this eval statements function, and so that just doesn't work for this use case. I suppose I can take a look at what other areas this is being used in, and it's not being used in many. Anyway, I'm actually just going to take a very short break and back. So maybe this abstraction as it stands was somewhat premature, and maybe I actually want to allow the area of code calling eval statements to provide the full scope, not just to construct the inner scope, or not to just kind of create a simple binding for the inner scope. But it really does, yeah, I don't really want to affect the full scope stack. This will always be a declaration. like one hack I could do is to put the to basically create a new scope stack from just one element of just one element, because it'll always be declarations, then call the bindings on those, and then extract it out of that single layer stack and pass it as expected. Another option could be, instead of taking the inner scope, take the kind of unevaluated bindings that are going to be attempted and bind all of those at the correct time. So that would be, if I take a look at the definition of bind, so that would be an expression on the left-hand side, a valref on the right-hand side, and yeah, that could potentially work, and still kind of, because I do, I do like having this limitation that it's this function kind of controls the creation of new scopes and prevents code elsewhere from invalidating this idea that if a new block is being introduced, then any bindings that are kind of introduced while creating that new layer, they can shadow items in the rest of the scope stack, but they can't actually modify them. So that might actually not be a bad idea, in my opinion. So it would basically result in refactoring eval statements to something more like, instead of taking the inner scope directly, it would be inner bindings or new bindings, and that would be a vector of pairs, because we can do them one at a time, and it would be expression valref pairs. And in the case of, and what I would be doing then is creating the new inner scope, and then I'd be doing a for each, so for binding, binding in new bindings, we would do this kind of a construction, and it would be LHS, and it would be RHS, I suppose. And it would be inner scopes. And that will be the change that's needed there. Now, I've kind of done a kind of a refactoring at the same time. Well, actually, this is all going to be related to a bug fix, so it's kind of the refactoring in this sense is the bug fix. So that shouldn't be too big of a deal. But the thing I want to check now then, whoops. Also, I should really get used to one thing that I never quite got acquainted with in Vim are using marks. I tend to just split the window where I want to leave my cursor, and then I can go back to it. That works for me, so that's probably all right. So in this case, the inner scope, again, I could create the binding. How? In fact, yeah, I should attempt creating that binding first. So let new bindings is equal to vec and entry. That's a relatively straightforward one. New bindings, and it also gets rid of a bit of code. I think it actually improves the comprehension somewhat as well. So let me see then. Inner scope. So instead of an inner scope, we'll instead have new bindings as well. And this will be, instead of pairing arg names, well, that'll still be like that for the moment. It's just that the arg names will need to be converted into string expressions. Are they already string expressions? No, I think they're just strings. Bit weird to introduce to construct an expression in the evaluator, just because I haven't done that before. However, the intention would be to remove that in the next step if this even works. So yeah, the new bindings. So how does this work? So it clones the existing arg names, turns it into an iterator. Whoops. Zips the values with, so I'll first have to do a map, I would say, to convert Rust hash map. No, what am I doing? Just regular map. Okay, Rust map function. So I can do potentially that kind of a lightweight syntax, maybe, even though I prefer block syntax in general. But so I have an arg name, and I'll use that to create an expression, which will be a var name zip it with vals and then collect those up. So that will be the new binding, and so instead of inner scope, I'll have new binding. That's a tuple, so I don't need to mess around with values or types, I don't think. New binding, new bindings. So that's that. Eval statement's done. Global scope, I'll have to modify main. New bindings in this case is kind of nice because it's just an empty vector. And that's basically all of them actually. So if I update main, then so that's global frame, that's the second. So I'll call this instead global bindings. Use AST expression. How will this be fixed in the next version? I can't really fix that. I can fix the other one because I will actually be replacing the argument names with expressions in the AST builder, but that will not be the case here, and this would then yeah, not quite sure. Not sure how to sort this one out. So new bindings, expressions to val refs. And is there maybe I could just put it directly into the scopes. No, was that what I was going to do before? No, because they'll be pushing a new kind of frame either way, and I want the don't want to add an extra frame. Yeah, maybe I'll just do it the obvious way and kind of worry about the consequences later. So name, I probably still have to keep these as tough strings. Expression var name that, and put that there and that there. Oops. Now, I'm still not sure that this is actually going to work, which is a bit scary, but should be all right. And everything seems to be updated with it. I suppose the main thing that could throw up a bit of a fuss is is the borrow checker. So let's take a look at what the obvious errors are anyway. Eval.rs line 51. Line 16. Global scope eval program. So that just needs to be changed to global bindings as well. I wonder if that type is still being used in many places. Yeah, it's used pretty liberally in the scope stack definition. Forgot to add that. Eval statements, evals statements in a new scope appended to pushed onto scopes with the given new bindings declared in the new scope. It returns that. Line 20, that has to be a thing like that. Main. What's going on? Main 32, closing to limiter not found. I'm certainly missing something up here, so I actually needed to keep the second of these braces or parentheses on each line. File 811 new binding is and then the others are for main as well. Line 40 global frame should be global bindings. Now this is a very risky change to be making realistically in a project that doesn't have any unit tests as of yet, but you know it is kind of a work in progress to more give a demonstration of the features. Brilliant, nice one. That's exactly what I wanted. So that is, yeah, that's fixed that issue. So we've got the pairs. So with that all said and done, don't add for loop to enclosing scope. Will I have enough characters for that? 47 characters. Nice. I'll push that. That is a nice chunk of work done. What else? So the next thing I wanted to do, and so so yeah, kind of running up against time at this point. Oh, I can do the stash pop now, I suppose. Issue in source test. So the actual feature that was going to be implemented then was destructuring in function parameters. So with that said, names. So I need to do the same for function expressions, and I'll just use a param list instead. Oh, I'm importing something that I'm not using. Oh yes, in main. Oh, I've already pushed, haven't I? Yeah. So I'll just do that in a subsequent commit. Val.rs 224 args clone expected string. Yes, so this is where things change now. So a value func first of all will what's this bind name? Oh yeah, that just binds the new function. So function value is now, instead of args, it's a list of expressions. Whew. That is an issue with the AST, is it? Func. Yes, because there is function expression and function statement. Expected struct string found 806. Yes, and this is the thing that gets cleaned up by allowing the expressions. Can remove that mutability in main as well. And if I'm not mistaken, that does what I wanted to do. Nice one. So just remove the mutability there. Fantastic. That's very cool. Fairly painless implementation as well. I'll just double check that it actually, like, I'm fairly certain that it's printing the way I want it to, but just to make sure, I'll put a little hyphen between the lines. Yeah, nice one. So that that is variable destructuring in function parameters. So let's see what we've got here. So first of all, I'll reset head so that not all those changes are in there. Whoops. First, I'll add the changes from main on the things that weren't necessary anymore. Git commit, remove unnecessary remove redundant then next, yeah, update that. No, I'll remove you for good. That is in the LALRPOP. Yeah, and keep all of those. And while I'm waiting for that to compile, I'll just take a look at the to-do list as well. So pair isn't defined. Yeah, that's what I wanted. So git commit. And this will be, what's the name? Allow, add variable destructuring in function arguments. I know I keep calling them parameters, but they're, well, I suppose there probably isn't too much agreement on exactly the difference, but in function arguments, yeah. And that was, that's good. That was 14 lines of code, 8 lines of code because of 6 deletions. Hang on, did I commit that code accidentally? No. So all that changed. Oh yeah, so all that changed was I changed them from strings to expressions, and that was all. And the binding the logic for destructuring was already implemented in the binding function, so just kind of got it for free. So that's pretty nice. So destructuring function parameters. Const assignment could be a straightforward one. Let's take a look. Just conscious that there isn't too much time before the end of the hour, so let's see what can be done in that much time. No, that's main. I want eval. And the idea here is that, I suppose just thinking about it briefly now, a val ref no, the reference itself won't have mutability semantics, but the bindings will. So that'll basically come into play here. And whether I want to whether I want to change that to a struct or a tuple, I'm not sure. A struct would probably be more explicit, so I can actually say, is const or something like that. So struct binding is const. No, these are meant to be lowercase. Is const bool and the val ref. So a lot of code is probably going to have to change for this, but yeah, good chunk of code is going to have to change for this. I also already have a binding. Our bind type, isn't it? Yeah, whereas it's another type of bind type and probably a more accurate name for bind, or a more accurate concept for bind type. Just call it bind type 2 for now, and I'll refactor that before I commit it. I'll just check, can I actually commit that now? So I'll add everything and git commit. No, so it's saying changes containing no commit keywords were found. It shows me more than what's in the actual commit, unfortunately, but if I were to remove that, that should still allow me to commit. Anyways, bind type, so it could be a constant or variable. BT bind type. So when you declare it, and then when you assign once you get the binding, oh, maybe I'll just call this mutability. I feel like these days mutable nearly refers to like a deep property, whereas constant is nearly more kind of shallow. Like I could just, like, it is a Boolean property, but just feel like giving it a proper name, make things a bit clearer. Anyway, insert probably don't need that if well, if I have that binding type. Anyway, contains key. So before we could just do contains key, but now I'll actually have to do like a try get, because we actually want information from the entry. So get key value. So it would be let some kv get key value. If bind type is it, yeah, I can just derive equality. So if bind type is equal to bind type 2 constant. Oh, and this means that yeah, this has to change to a result now as well. And returns true. And returns true, returns false, or else sign returns an error if attempting where do I check whether a declaration is being attempted for an a variable that already exists in the current scope? Can't remember. Bind name. So I'll just do a git stash again, and check if I have another kind of bug in my programs. So let's see, let x is equal to 1, let x equals 2, and print x. Okay, so I allow shadowing at the moment. Now, whether I want to keep that behavior, I don't know. Because this could potentially hide errors. Yeah, maybe that'll be it to do. Prevent declaring same variable in the same scope. But for now, that should be alright. So assign returns an error if attempting to assign to a overwrite to a. oops. I'll git pop that, and, oh, git slash pop, and yeah, I'll overwrite. Yeah. So if bind type is a constant, otherwise it can be inserted, and so in this case, return OK true now, OK false, and otherwise I can return an error to say format, and what's the error message here? Cannot to constant. That should be all right for the moment. BT. Okay, so then bunch of new errors. Result bool. Oh yeah, and it's usually string that I use at the moment, isn't it? Not advised, but yeah, I was thinking as much, and can probably just bit of a waste, but that's all right. Yeah, just need to drive equals there. Partially. Oh, yeah. Comparing a reference to a can I just take it out of the reference temporarily? Need to be able to do that, and probably need to be able to clone it as well. 366. So so let R is that. Oh no, so this will be a match now. And if it's okay, then we check or maybe I should just since now this can return multiple errors. So the bool was basically encoding the error because that was the only type of error that could occur. But since multiple types of errors can occur now, it might make as much sense to just to handle them as errors. So name, yeah. So in that case, it would be an if let error e is equal to that, then just return the error at the minute. So that's that. And then 371. Yeah, and this will, this is going to be making things a little messy, but so bind type is a const declaration or let declaration now as well. And that will be converted to bind type to constant and bind type to variable. Oh no, it's those up. Call that var declaration instead. And actually that might not be so bad. So then what needs to be updated instead? 374. 233. So in eval statements, in general, unless you specify a constant, will constants be allowed in the for loops and function bindings? I'm not sure. Don't think there's a great need to right now anyway. Declaration. Okay, and so then that's the last one, which will be determined by whether it's using just the let or const keyword. Actually, that'll be a, I'll call it a declaration type. And declaration. So declaration type dt. It can be var or const. And I'll do the same for I'll replace bind type 2 with declaration type. I'll need partial equality on this. And so declaration, oh, no, I better hang on a tick for that. So I want this to be the result of a match, the declaration type. So if it's I import the AST like that so that I can't declare the same type locally. I do think I want to decouple the AST from the evaluation file though, so I will declare that type twice. Oh, that's bind type var declaration and oops. And then bind type 2, that will be and then that's probably it. No, no, absolutely not, apparently. So what's going on here? So I'm missing DT there anyway. Shouldn't take much longer to round this out, hopefully. Yeah, Rust compilation times are slowly creeping the last while. Inval 86. Oh yeah, didn't actually specify the thing that I was matching on. 1018. Not actually using K. Yeah. And with that done, let's see if oops, if I can test it. Const x is equal to 1. Let y is equal to 1, y is equal to 2, and then that should be fine, and then x is equal to 2 should cause an error, in theory. Yeah, canon assigned to constant binding. Nice one, cool. And that is constant declarations implemented. So still took a bit longer than expected, but not too bad at the end of the day. And git commit that. So add support for const variable declarations. And cool. So with that done, I'm just gonna mark that off the old to-do list. So that finishes that new section. Add variable destructor. That's not sure where that's meant to be. Assignment. Destructuring bindings. Add variable destruction for loops. Yeah, that's just contained in that. And that gets rid of that. And so cool. That is yeah, there's been a bit of feature creep today, but kind of working ever forward towards this kind of basic core. In terms of the work that's left, object enumeration should be very straightforward, assuming that Rust gives kind of a simple interface for iterating through entries in a hash map, which it most certainly does. String enumeration could be a little tricky because it'll require me actually being specific about the exact representation of strings and what iterating through a string involves, because I do think that will be different to how Rust defines it, whereas Rust defines it in terms of UTF-8 runes. I would probably keep things simple and just define it in terms of byte arrays or an array of integers, which will still be strings, but yeah, it'll need a bit of teasing out. Else if, yeah, that'll just be a tricky one that I need to just knuckle down and figure out. Destructuring object assignment. Now I'm not sure about that one because I feel like that's implemented already, no? So test 5. Yeah, that's more or less, or that's this one. It's just duplicated in the 2 spots. So if I do that, maybe. So what's left to do there? Confirm evaluation of keys. So if I don't think I have a shorthand for this yet. I thought that was something I was going to do, so that if well, I'll just check if I put test there, and I also want to do demo method. Oops, that's with closure. It should be a straightforward enough one. Let me just check whether this got implemented. So allowing, because I think it might have. And if I have just C there, C should, print C should give me just 3. Okay, yeah, so that that's been implemented. In fact, do I have that? I probably have that listed down here somewhere actually. Decomposition or destructuring. Yeah, shorthand. Probably should have just read that. Confirm evaluation of keys, so that if there's a value on the left-hand side, that it'll be expanded to a string, and it makes sure it's a string. So that should be relatively straightforward. It's very similar to what was done with the functions today. Most of the work is already done by the binding function, so it shouldn't be too difficult. Hopefully, famous last words. Prevent reassign to the same name more than once should be straightforward, just an extra limit to add. String and array ranges, again, string could be a little trickier, but like once the semantics have been worked out for either loops or indexing, then that work should be possible to reuse that for the other. And I don't think there's anything too difficult in this as such. It's just a matter of, you know, doing it really. In fact, there'll be a bit of work on this at the syntax level, but the evaluation semantics should be relatively straightforward. Destructure bindings, just checking for any other binding introductions. I think that's actually captured by the new statement eval statements function. So I don't think I actually really need to put extra time into that. And introduction of the this keyword for evaluating methods. And yeah, because I have it have a snippet written out here, actually I might just go ahead. It's coming up to the half hour now. I'll finish up at the half hour, but just to round out this stream, I'll just add a demonstration of closures, just to prove to myself and others that it works. Hopefully, might not actually be implemented, which would be fun, but are all the necessary features. But I think they should. I think it should all be here. So set set k is equal to true. Actually, yeah, not everything has been implemented for this. Actually, I'm missing error handling, certain error handling semantics that are necessary to make this work. But we'll try this and let x's is new set, and x's set A, x's set B, and print x's has a x's has C will crash it, but at least demonstrate, the functions are there, demonstrates the use of closures for kind of defining objects and data hiding and encapsulation and all that. So error unrecognized token, where is that coming from? Yes, those need to be strings. Invalid token. Oh, yeah, because I don't have a method. Ooh, that's a big one, actually. Method called shorthand. So that should be a straightforward enough one, but big big implications. I don't. I won't get into it now, but I'm not the biggest fan of the method called shorthand, such as it is in JavaScript. I think it probably is as good as it can get, but I don't like the overlap. The fact that you then have two ways of functionally accomplishing the same thing. But I suppose that's a minor grievance in the grand scheme of things. Let's see, unwrap on error value, unrecognized token, 197. Oops, 197. One four one. Anyway, I suppose I'll leave it there. Thanks very much for watching, everyone. Yeah, need to figure out what exactly is going wrong there. Taking a string as a passing a string to a function as an argument doesn't seem to be working, but it'll get figured out. Anyway, thanks for watching, and yeah, see you next time. Take care. Bye.